Hello everyone, I hope all of you are fine. So my name is Shubham and today we'll be continuing with the next topic in this video, that is the heating effect of electric current. Before starting this topic, I would want to talk something on this topic, that is the heating effect. You must have heard something of it. As we can clearly see, whenever we have this high voltage bulbs in our homes, the yellow colored bulbs, they get heated up very quickly. है ना, ये तुम लोगों ने देखा होगा. It means that they have high heating effect. High heating effect means whenever the electric current flows through a circuit, so the bulb starts getting heated up, and basically this phenomena is known as heating effect of electric current. Let's try to study it in detail. It says we know that the battery or a cell is the source of electrical energy. This means we have understood that battery or cell gives us the electrical energy. Electrical energy means a sort of current. So we get the current from the battery, and that is why we call battery as a source of electrical energy. The chemical reaction within the cell generates the potential difference. Whatever the chemical reaction takes place inside the cell, it will help to start a potential difference, or it will help to generate a potential difference between the two terminals. Means, for example, this is a sort of battery and a bulb is connected across this battery. Now we know that this is the positive terminal of the cell, this is the negative terminal of the cell. So current will start flowing in this direction, and ultimately it will come back through this direction. And I told you earlier as well that whatever amount of current battery takes, the battery gives, the battery has to take that current as well. So that current will be getting into the battery through this path. तो बैटरी जितना करंट देगी उतना करंट इस पाथ से वापस आ जाएगा. और what is the reason behind all these things? And all these things, the reason behind these is the potential difference. Means whatever the potential difference has been created in these two terminals, whatever the potential difference has been created in these two terminals, due to that potential difference the current is flowing. Okay, so current also flows due to the motion of electrons. What it says, it generates the potential difference within the two terminals, which sets the electrons in motion and flows the current through a resistor. Now the electrons are set to move from negative to positive, means electrons will move in this direction. This will be the motion of electrons, and current flows in the opposite direction of electrons. So this will be the motion of current. Electrons इस तरफ जाएंगे, current इस तरफ जाएगा. So we can say that current flows from positive terminal of the battery to the negative terminal, and electrons flow from negative terminal of the battery to the positive terminal. Now we are keen to know that to maintain this current, the source has to keep expending its energy. Expending means expelling. Expelling means giving out. The source has to be someone which should be continuously giving its energy. For example, consider your remote cell, or consider a cell in your toy. The remote or toy works only till that time, till the cell or battery is working. Once the cell or battery stops working, the toy doesn't work, है ना. It means हमारा सेल एक ऐसा सोर्स है एनर्जी का जो कंटिन्यूसली एनर्जी उसको देते रहनी चाहिए ताकि हमारा जो काम है वो होता रहे. Now where does this energy go to? अब एनर्जी जाती कहाँ पे है? A part of the useful energy is maintaining the current. Of course ये बात समझ आ गई होगी अपने को कि whatever current has to be drawn from the battery, some energy has to be used up. So a part of this energy is used up in the current, and बाकी जो energy बच जाती है, means the rest of the energy or rest of the source energy may be expelled into heat. Whatever the extra amount of energy is left after giving the current to the battery, so that the bulb, the fan, the tube light, or any electrical appliances for that matter could be lit up, that extra amount of energy is converted into heat, which heat is used up in raising the temperature of the gadget. Means जो एनर्जी तो गैजेट ने यूज करनी है चलने में, वो एनर्जी को यूज कर लेगा, एंड एक्स्ट्रा अमाउंट ऑफ एनर्जी इज ऑलवेज एक्सपेल्ड एज हीट. बाकी बची हुई एनर्जी हीट की फॉर्म में वो बाहर निकाल देगा. दिस वी ऑब्जर्व इन आवर डेली लाइफ. फॉर एग्जांपल, एन इलेक्ट्रिक फैन बिकम्स वार्म if continuously used for a longer time. This you must have learnt about. On the other hand, if the electric circuit is purely resistive, that is configuration of resistance is connected through a battery. If only the resistors have been connected through a battery, the source energy continually gets dissipated entirely in the form of heat. Means more the number of resistance, more will be the heat. Let's write it here as well so that you can note it down. More the number of resistors, more will be heat expelled. Means whatever will be the number of resistors, the heat will be expelled as per the number of resistors. Okay, let's move forward. So this effect is utilized in devices such as electrical heaters and electric iron. That is why they become heated when they are connected through electrical supply. तो हमारा हीटर और हमारी प्रेस जो होती है, कपड़े प्रेस करने वाली जो प्रेस होती है, that is the electric iron, it becomes hot. और so this effect is utilized in the devices like electric heater and electric iron. Now what we have done is, we know that what we have done previously in this chapter, we know that potential is defined as work done per unit charge. This we already know. Means whatever work is being done in bringing a charge from one point to the other, that is known as electric potential of that point. If you don't remember this formula, you can go to previous parts of the chapter as well. You can have a look from that part how this potential was coming out to be work done per unit charge, or you can refer to that page as well. So it says, consider a current I flowing through a resistor R. Let the potential difference across be V. So यहाँ तक तुम लोगों को समझ आ गया होगा. Let's have a look at figure 12.13 as well, what it is suggesting. Let's move to figure 12.13. So this is the figure 12.13 that has been shown in the figure. As we can see that a battery has the potential difference of V volts. Okay, and this is the resistor R, and this is the ammeter that has been connected with the battery. So battery will be expelling current I, as you can see in the figure, and the potential difference across this resistor would be V, and ultimately the current will be coming back through this battery. So this is what we have considered in this case. Let t be the time due which the charge q flows. मतलब हमने t टाइम के लिए मान लिया कि t टाइम के लिए हमारा चार्ज जो है वो q बैटरी से बाहर आ गया. So current is defined as the charge flowing per unit time. This you can also refer to the previous topics of this chapter if you don't remember. So current will be charge flowing per unit time. If potential is the work done per unit charge, so can I write work done is equal to potential into charge? So this work done will be potential into charge. I can write this as by cross multiplying this V into Q. So what we have done is, we are trying to calculate the power. Power is equal to, here in this case, power is equal to work done per unit time, and work done, we already know that work done is equal to V into Q. Work done is equal to V into Q upon time. I hope this is clear. This is the formula that they have written. Power is equal to work done into Q by T, and we know that current is charge flowing per unit time. So this Q by T, this Q by T part will be written as V into I. So we get our first formula for the, what you can say, power of that particular electrical circuit. Power is equal to voltage into current, that is P is equal to V into I. Now the energy supplied to the circuit by the source in time t is power into time. From where does this formula comes? Work has the dimensions, or work has the units equal to energy. So we can write power as well, power in this form as well. Power is equal to energy upon time. We can write power in this form as well. So whatever power is equal to energy upon time, so energy would be power into time. If energy would be power into time, so I hope this statement would now be clear to you. Energy supplied to the circuit by the source is given in terms of power by this expression. Kindly read this line very, very carefully, that whatever amount of energy is being given to the circuit, it is measured in terms of its power. So power will be energy upon time, and energy will be power into time. So I hope now this expression is clear. Energy is equal to P into T. Now P is equal to Vi, which we already calculated like this. As you can clearly see in this point, P is equal to Vi has been calculated. Now in this expression, P would be taken as Vi into T. So this will be the energy, and of course the energy what we have already been taking in this is the heat energy. The heat energy that we already talked about in this video earlier. This is the heat energy formula, and heat energy formula is VIT. So I hope this is clear, and we'll be continuing the next part of this in the next video. Now what you have to revise till here is the number of resistors that have been connected, more will be the heat expelled. Means whatever is the more number of resistors if are connected across the series combination, higher would be the heat expelled. And second thing that you have to take care is you have to be very careful with these formula. Power is equal to work done upon time. We have started from here. Power is equal to work done upon time. Work done was potential into charge. From here, work done was potential into charge, because potential is work done per unit charge. So we have put work as V into Q upon T, and we have replaced this Q by T. हमने इस Q by T की जगह इस expression से, from this expression we have written as V into I. So this is, I guess, clear. And the second thing that you have to be very careful about is the energy. The energy that we have to calculated energy to the circuit, of course. Energy to the circuit that we have to calculate, it will be P into T, and P is equal to Vi from this expression. So heat would be, or rather heat energy would be VIT. So revise till here carefully, and we'll continue in the next video. Take care. Thank you.